What's up, guys? In this video, what I want to do is show you how to write the equation of a line in slope-intercept form when you're given 2 points. Now remember, when we're looking for to write the equation of a line in slope-intercept form, we need to understand what the slope is as well as what the y-intercept is. So the first thing I'm going to do is I'm going to focus on slope, and that's what I want you to do when you're trying to write the equation of a line, is try to find the slope first, because typically that's going to be the easiest, especially when you're given 2 points, right? That represents an xy, and that represents an xy. But if I said, hey, what's x? How would you answer, 6 or -3? So therefore, what we want to do is kind of differentiate these. And that's why we use these subscripts of like x1, y1, x2, y2, is just to differentiate between these 2 points. Now to find the slope, you are going to need to know the slope formula. And the slope formula is going to be the change in the y coordinates over the change in the x coordinates. y2 minus y1, x2 minus x1. And again, it's very important for me to state that it doesn't matter the order, you just need to be consistent. Now I'm just going to simply replace these points with the coordinate points that I have to go ahead and find the slope. So now when I plugged everything in, it's very important to recognize that I used parentheses here and I didn't use parentheses here. And again, you could definitely put parentheses around the 6. I always like to do that when I'm inputting values. But the main thing I wanted you to see, the reason why I had to put them over here is because this y1 was a negative, right? So I'm subtracting a negative. It's very, very important to recognize that, because when you're subtracting a negative, that's a double negative, right? That's going to turn this to a positive. So a -3 minus a -3, right? It's really plus a 3. Well, that's just going to equal a 0. So it doesn't really matter what's in the denominator. But again, if you owe me $3, you borrow 6, that's going to be a -9. But again, your slope is still going to be 0. So therefore, m is going to equal 0. Now we have a case. We want to write this in slope-intercept form. Should we immediately jump right to slope-intercept form? Or should we go ahead and look at point slope form? In my experience, I like to go ahead and use point slope form, but in this example, it actually would probably be easier just to kind of stick with slope intercept form. And the reason being is because when my slope is going to equal 0, it's going to be really easy to go ahead and solve for b. So let's go ahead and write out here our slope intercept form. So we have y equals a mx plus b, right? Now I know what my slope is. That's going to equal to 0. Now what am I going to plug in for y or x? Well, y and x represents the points that make up our line that we're trying to write the equation for. And in our problem, we're given 2 points. Now, yes, I did label them x1, y1, x2, y2, but that was just to differentiate between the two. When you're trying to solve for b, you can pick either one of them. Or if you're given a third point, you could use the third point there. I'm just going to go ahead and plug in point number 1 as well as the slope to go ahead and solve for b. And now you can see I can just go ahead and simplify this. 6 times 0 is just going to be 0. So -3 is equal to a b. Okay, so now I have a b and I have my m. So now I have everything that I need to write the equation of the line. So now I can just write that in as y equals a 0 times x plus a -3. But again, we don't really write 0 times x. We can just leave that as 0 or just leave it off. And then plus a -3, we can just rewrite as -3. So my final answer is y is equal to a -3, which indeed is actually going to be a horizontal line if you think about that graphically. And now in this next example, we're going to do the exact same thing. We're going to try to find the slope first. And actually in this problem, it's actually going to be extremely important because it's actually going to help us avoid doing a lot of algebra, actually doing any work at all. Because if I go ahead and label this as x1, y1, right, x2, y2, right? And then you go ahead and plug it into the slope formula. So m equals the change in y. So 2 minus a 5 all over a -3 minus a -3. Okay. So again, I'm just make sure you're following the same order. y2 minus y1, x2 minus x1. And when I go ahead and do this, what I get is 2 minus 5 is a -3. And then -3 minus a -3 is going to be 0. Now this has a problem, because our slope is now undefined. So not only is that something we can't plug into a linear equation, but we have to actually understand exactly what is going on with an equation like this. Now remember in the last example, I had y equals -3 was a horizontal line. So when the slope is equal to 0, you're going to have a horizontal line. So guess what? When the slope is undefined, you're actually going to have a vertical line. And I can actually prove that to you by actually plotting these 2 points. So sometimes if you are getting a little bit confused and you're trying to write the equation of a line, just go ahead and plot the points to kind of get a visual understanding. Like, do you have a positive slope? Do you have a negative slope? Do you have a vertical line? Do you have a horizontal line? You can always kind of roughly check your answer or make sure you're on the right track by doing that. So you can see here, I just went ahead and graphed the 2 points, -3,2 and -3,5. And you can see what's going on here is exactly what is happening is I'm creating this nice little vertical line. So how do I write the equation on vertical line? Well, y equals a -3 represented a horizontal line. So if you can see, this is the x-axis, right? And this is the y-axis. So the x coordinate is always equal to a -3, right? It doesn't matter what point I pick on this line, x is always going to equal a -3. So that indeed is going to be the equation of our line. And it was really helpful because if I can recognize that my slope was undefined or if my slope was 0, you can write the equation of the line pretty quickly. All right, so how about when we have a problem like this? Well, again, we're going to follow the same steps, right? So we're going to do x1 and y1, and x2 and y2. So let's go ahead and find the slope of this equation. So my m is going to be my y2, which is going to be a 1/4 minus a negative 3/4. Okay, and that's going to be all divided by x2, which is 2/3 minus a 1/3. Okay, so remember when we're subtracting fractions or adding fractions, you got to have the same denominator, which in this case they do. So I have a 1/4 minus a 3/4. Well, that's just going to really be adding. So 1 plus 3 is 4. So therefore, that's going to be a 4/4. Now that's equal to 1, but I'm just going to leave it like this for a second. Now here I have a 2/3 minus 1/3. So that's going to be reduced to a 1/3. Okay, so really this is a 4/4 divided by 1/3, which is really the same thing as a 1 divided by a 1/3. Now, how do I take a number and divide it by 1/3? You just simply multiply by a reciprocal, right? Dividing by a fraction is the same thing as multiplying by a reciprocal. So in this case, what I have here is if I took 1/1/3, that's the same thing as 1 times a 3/1, which is just 3. So 1 times 3 is going to be 3. So therefore a m is equal to 3. All right, so I have my slope, m is equal to 3. Now, unfortunately, that's not 0 or undefined like my last example, but that's okay. We can still write the equation of the line. Now, in this example, what I prefer to do is use point slope form rather than just immediately going into slope intercept form. So what I'm going to do is I'm going to take point slope form, which again, if you forgot, it's just going to be y minus a y1 equals a m times a x minus x1. All right, and we already have m, so that's easy. That's going to be equal 3. And then for my x1 and y1, I'm just going to plug in the point that I was originally given, which is a 1/3 and a negative 3/4. Okay, and now I just simply need to go ahead and simplify. So a couple important things here. I do need to distribute this 3 across here, and then I can rewrite this as a minus a negative. I can rewrite that as a plus. So therefore, I have a y plus a 3/4. Let's go ahead and fix that plus to 3/4 equals a 3x. Now 3 times negative 1/3 is going to be a minus 1. Now I just need to go ahead and solve for y, right? We want to put this in slope intercept form. So I'm going to go ahead and subtract a 3/4 on both sides. Okay, so in doing that now, I have a y is equal to a 3x minus 1 minus a 3/4. Now again, subtracting a whole number minus a fraction, I got to get that to be same denominators. So what I can do is I can just rewrite a 1 as a 4/4, right? Didn't you agree? Remember over here, we did that. Like 4/4 is equal to 1. Well, if I have a 1, can I rewrite that as a 4/4? Yes, of course you can. Now, why is that helpful in this case? Well, the reason why that's helpful in this case is because if I write this as a 4/4, I now have the same denominators. And that's exactly what I need to be able to add or subtract fractions. Now, in this case, I have a negative fraction minus another fraction, right? So this is like you owe me 4/4, and then you're going to borrow 3 more 4s. You're now going to owe me a negative 7/4. So y is equal to a 3x minus a 7/4. So there you go, ladies and gentlemen. That is the step-by-step example to writing the equation of a line when given 2 points. I hope you also benefited from the horizontal and vertical line method. It doesn't matter if you have fractions or integers, the process is going to be exactly the same. However, if you need more examples on writing the equation of the line, or you want to go and take a look at the notes and resources that I provided my students inside my courses, then go ahead and check out the playlist and information I have for you down below. Or you can check out the next video I have designed for you here. Cheers.